Good morning. I am Devasena. In this lecture, we are going to discuss about special cases in Routh-Hurwitz criterion and its problems. This topic is present in the subject Control Systems. Special case 1. When there appears a 0 in the first column of any row and having one non-zero element in that row. First method. Now replace S by 1 by Z in characteristic equation. Rearrange the characteristic equation. Proceed to complete the array and apply RH criterion. Second method. Replace 0 element by epsilon, where epsilon is a small positive number tending to 0. Complete the array, then examine the limiting values as epsilon tends to 0 and hence apply RH criterion. Special case 2. When all the elements of row are 0. Solution to the above. Let pth row have all 0 elements. Frame an auxiliary equation A of s using coefficient of preceding row, that is p minus 1th row. Find A dash of s, that is differentiation of A of s with respect to the s. The coefficient of A dash of s are the new numbers of pth row. Complete the array and apply RH criterion, that is Routh-Hurwitz criterion. Special case 1, problem 1. For the following characteristic equation, s power 5 plus s power 4 plus 2s cube plus 2s square plus 3s plus 5 is equal to 0. Find the location of roots using Routh-Hurwitz criterion. Solution. Here we have to identify the coefficients of the given characteristic equation. The coefficient of s power 5 is a0. a0 value is equal to 1. The coefficient of s power 4 is a1. a1 is equal to 1. The coefficient of s cube is a2. a2 value is 2. The coefficient of s square is a3. a3 is equal to 2. The coefficient of s is a4. a4 is equal to 3. And the constant term is a5. a5 is equal to 5 for this given problem. We have to construct the Routh's array with the help of the coefficients. a0 is equal to 1, a1 is equal to 1, a2 is equal to 2, a3 is equal to 2, a4 is equal to 3, and a5 is equal to 5. The Routh's array is constructed with the help of these coefficients. In this given equation, the highest power is s power 5. So we have to construct s power 5 row, s power 4 row, s cube row, s square row, s power 1 row, s naught row. S power 5 row is constructed with the help of even coefficients a0, a2, a4, that is 1, 2, 3. S power 4 row is constructed with the help of odd coefficients, that is a1, a3, a5, that is 1, 2, 5. Now with the help of this s power 5 row and s power 4 row, we have calculated the value of s cube row, that is b1 is equal to 1 into 2 minus 1 into 2 divided by 1, its value is 0. b2 is equal to 1 into 3 minus 1 into 5 divided by 1, its value is minus 2. Here in this s cube row, in the first column of the Routh's array, we have 0 value, and that s cube row comprises of at least one non-zero element. So this problem comes under solution 1. In this problem, the Routh's array is broken at s cube row. It stops with the power of s cube. So The element of first column of S cube row is 0. It corresponds to method of special case 1. So replace S by 1 by Z in the characteristic equation. After substituting the value of S is equal to 1 by Z in the given characteristic equation, the new characteristic equation becomes 1 by Z the power 5 plus 1 by Z the power 4 plus 2 into 1 by Z the power 3 plus 2 into 1 by Z the power 2 plus 3 into 1 by Z plus 5, that is equal to 0. Now simplify the above equation and rearranging, we get 5z power 5 plus 3z power 4 plus 2z cube plus 2z square plus z plus 1, that is equal to 0. Frame the Routh's array for the above characteristic equation. Now the characteristic equation is 5z power 5 plus 3z power 4 plus 2z cube plus 2z square plus z plus 1, that is equal to 0. For this new characteristic equation, the new coefficients are a0 is equal to 5, a1 is equal to 3, a2 is equal to 2, a3 is equal to 2, a4 is equal to 1 and a5 is equal to 1. With the help of these new coefficients, we have constructed the new Routh's array. The new Routh's array is having the values z power 5 row comprises of the coefficients a0, a2, a4, that is 5 to 1. Z power 4 row comprises of the coefficients a1, a3, a5. Its value is 3 to 1. With the help of z power 5 row and z power 4 row, we have calculated the value of z cube row, that is b1, b2, b3. b1 value is 3 into 2 minus 5 into 2 divided by 3. Its value is minus 1.33. b2 value is 3 into 1 minus 5 into 1 divided by 3. Its value is minus 0.67. The value of b3 is equal to 0. Similarly, z square row is calculated with the help of z power 4 row and z cube row. So z square row comprises of C1, C2, C3. The value of C1 is equal to minus 1.33 into 2, close the bracket, minus open bracket 3 into minus 0.67 divided by minus 1.333. Its value is 0.49. And similarly, the value of C2 is calculated, that is 1. With the help of z cube row and z square row, we have calculated the value of z power 1 row, that is d1. d1 value is equal to 0.49 into minus 0.67, close the bracket, minus open bracket, minus 1.33 into 1 divided by 0.49. If you simplify, this means we get 2.04 and d2 value is equal to 0. Similarly, we have calculated the value of z0 row, that is 2.04 into 1 divided by 2.04. Its value is 1. There are two sign changes in the first column of the Routh's array between z power 4 row to z cube row and z cube row to z square row. Result, therefore, the system is unstable. Two roots are lying on the RHS of the S plane. Special case 1, problem 2. For the following characteristic equation, s power 5 plus s power 4 plus 4s cube plus 4s square plus 2s plus 1 is equal to 0. Check the stability of the system using RH criterion. The solution for this problem. The given equation is having the highest power s power 5. So we have to calculate the values of the coefficients with the help of the characteristic equation. Coefficient of s power 5 is a0. a0 is equal to 1. Coefficient of s power 4 is a1. a1 is equal to 1. Coefficient of s cube is a2. a2 is equal to 4. Coefficient of s square is a3. a3 is equal to 4. Coefficient of s is a4. a4 is equal to 2. The constant term is a5. a5 is equal to 1. Routh's array comprises of the following formulas. In this problem, the highest power is s power 5. So, the s power 5 row comprises of a0, a2, a4. S power 4 row comprises of a1, a3, a5 values. S cube row is constructed with the help of s power 5 row and s power 4 row. S cube row is having b1, b2, b3 value. S square row comprises of c1, c2 value. c1, c2 is determined with the help of s power 4 row and s cube row. And s power 1 row comprises of d1, d2. This d1, d2 is calculated with the help of s cube row and s square row. And s0 row comprises of e1. Routh's array is constructed with the help of a0, a1, a2, a3, a4, a5 values. The s power 5 comprises of 1, 4, 2. That is a0 coefficient, a2 coefficient, a4 coefficient. And s power 4 comprises of a1, a3, a5. That is 1, 4, 1. And we have calculated the values of s cube row. S cube row is b1, b2. This b1 is equal to 1 into 4 minus 1 into 4 divided by 1. Its value is 0. b2 value is 1 into 2 minus 1 into 1 divided by 1. So s cube row is having 0 value in the first column of the Routh's array. In this problem, Routh's array broken at s cube row. So the element of the first column of s cube row is 0. So it corresponds to special case 1. Replace s by 1 by z. Therefore, the characteristic equation becomes 1 by z the power 5 plus 1 by z the power 4 plus 4 into 1 by z cube plus 4 into 1 by z square plus 2 into 1 by z plus 1, that is equal to 0. Now simplify the above equation and rearranging, we get z power 5 plus 2 z power 4 plus 4 z cube plus 4 z square plus z plus 1, that is equal to 0. Frame the Routh's array for the above equation. Routh's array is constructed with the help of the new characteristic equation z power 5 plus 2 z power 4 plus 4 z cube plus 4 z square plus z plus 1, that is equal to 0. This is my new Routh's array. New Routh's array is having z power 5 row, its value is 142. Z power 4 row is having values 241. Z cube row is calculated with the help of z power 5 row and z power 4 row. Z cube row is 2 and 0.5. Z square row is having the values 3.5 and 1. It is constructed with the help of z power 4 row and z cube. Z power 1 row comprises of minus 0.07. It is calculated with the help of z cube row and z square row. Z0 row is having the value of 1. It is constructed with the help of z square row and z power 1 row. There are two sign changes in the first column of the Routh's array between z square row to z power 1 row first sign change and z power 1 row to z0 row the second sign change. So the system is unstable. Special case 2, problem 3. The characteristic equation of a control system is given by s power 4 plus 2s cube plus 6s square plus 8s plus 8, that is equal to 0. Comment on stability using Routh-Hurwitz criterion. Solution. First we have to identify the coefficients of the given characteristic equation. S power 4 rows coefficient is A0. A0 value is equal to 1. Coefficient of S cube is A1. A1 is equal to 2. Coefficient of S square is A2. A2 is equal to 6. Coefficient of S is A3. A3 value is 8. And the constant value is having the coefficient A4. A4 is equal to 8. Routh's array is constructed with the help of these coefficients A0, A1, A2, A3 and A4. The Routh's array is given below. It is having the highest power of S power 4. S power 4 is constructed with the help of A0, A2, A4. It is 1, 6, 8. S cube row is constructed with the help of A1, A3 and A5. That is 2, 8. S square row is calculated with the help of S power 4 row and S cube row. Its value is S square row value is 2, 8. S power 1 row comprises of 0, 0. It is calculated with the help of S cube row and S square row. Here all the elements of S power 1 row is 0. Hence S square row is taken as auxiliary equation, because if a complete row is having 0 values means it comes under special case 2. For solving this special case 2, we have to consider the row just prior to the 0 row. Here S power 1 row is having 0 values, so we have considered the auxiliary equation from S square row. That is, auxiliary equation value is A0 of S. A of S is equal to 2, S square plus 8 is equal to 0. Then we have to take the derivative of that auxiliary equation, that is dA of S by ds. So its value is 4s, that is equal to 0. Now the coefficient of S power 1 row is 4. S power 4 row comprises of 160. S cube row comprises of 280 values. S square row comprises of 28. S power 1 row comprises of 40 values. And S0 comprises of 8. There is no sign change in the first column of the Routh's array. Result: the system is stable. All roots are lying on the LHS of the S plane. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.